to go over common factoring. And common factoring deals with looking for a value or a term that comes out of every number in a polynomial. So we want to make a couple definitions before we go through this. First of all, the number that's attached to a variable is called the coefficient. The symbol or the letter is known as the variable. And actually, I just realized I don't want this last number. Okay, this is known as the variable. When common factoring, we look for the greatest common factor of the coefficient. So we're looking for the greatest common factor in the coefficients. And we're looking for technically what's known as the greatest common factor of the variable. But it's a little different the way we'd find that common factor. So if we're looking for greatest common factors of coefficients, we're going to take each of them, and you might be able to see it right off the bat. We're going to take each of them and write out their factors. And just to make this more difficult, I'm going to make that number 35. Okay. So we're going to write out the common, or the factors of these numbers. So we have 35, 20, and 15. I want to write out all of the factors of each of these numbers. What are the factors of 15? 1, 15, 3, and 5. Good. What are the factors of 20? 1 and 20, 2 and 10, 4 and 5. Excellent. What about the factors of 35?
1, 35, 5, 7.
That's it. Good. So we have all the factors of each number. There are many common factors, but we're going to be looking for the greatest one. Okay? So obviously 1 is a common factor. What's the next common factor? That's right, 5. And it just so happens 5 is the greatest common factor. Sure, let's go with that. Okay. So since that's the greatest common factor, that number becomes very important to us. So we know that the greatest common factor of the coefficients is the value of 5. We're going to write that out. Now, greatest common factor of the variables. There's a very quick trick to it. I'm going to write out the long part and then teach you the trick. The very first term is x cubed. The second one is x squared. And the last one is x. What exponent is this x to? 1. So in other words, I can break this into primes by writing x times x times x. This can be written as x times x, and this can be just written as 1x. We need to take as many x's out of each one as we can. In this case, how many can we take out of every single one? We can only take 1 out. After that, there's none left here. So the idea is that the greatest common factor to the variables is just x, or you could write it as x to the power of 1. Now, the trick for that is to look at all the variables, and we just take the one that has the lowest exponent, and that will become the greatest common factor. Okay? That's a quick way to do it. So what that means is our greatest common factor is 5x. So we're going to combine the two, and the common factor we're going to take out of everything is 5x. So we rewrite this. 5x is going to come out of all of these terms. And I'm going to rewrite the actual term on top. 35x cubed plus 20x squared minus 15x. So, since we just discovered that the greatest common factor is 5x, we're going to divide each of these by 5x. So, to start off, this 5x now comes to the outside of a set of brackets. We write our bracket, and we're going to divide the coefficients to start. What is 35 divided by 5? 7. Good. What about x cubed divided by x? X squared. That's right. We just subtract the exponents. 3 minus 1 is 2, so we get x squared. The next set, positive 20 divided by 5. 4. X squared divided by x? That's right. 2 subtract 1 is just 1, so x to the power of 1. And what is negative 15 divided by 5? 3. X divided by x? They cancel out. So there is no x left over here. It's technically x to the power of 0. Any exponent to, or any number to the power of 0 is 1. 1 times 3 is just 3. So we don't need to write it in. Okay? So this is our common factory. Our greatest common factor is 5x, and we wrote it as factor form. It's 5x times 7x squared plus 4x minus 3.